Alrighty, folks. So today we are going to talk about glaciers and the ice ages a little bit. Actually, I'll probably break just before the ice ages because I wanted to add a few things to it. And I'm not going to sit here and take up class time to do that. But that's where we'll head next with this. So a glacier. I suppose when I think of glaciers, I don't know about you guys, I don't know how much you think about glaciers. A handful of things come to mind. You might know, living where you guys do, about the Finger Lakes, that they were carved out by glaciers. You might know, hearing people grumble, not even necessarily farmers, but just folks working on their yard, about all the damn rocks everywhere. You'll hear that the glaciers dumped a whole bunch of rocks here as they were melting back. And maybe even, and this is a stretch, you heard that just south of Syracuse is a whole herd of drumlins, a drumlin field. All right, and those are weird shaped hills, again, mounds of debris that were shaped and left behind by the glaciers. I've driven down 81 South a lot, maybe some of you guys have as well, and yeah, they just look like hills. But from the air, apparently, and yeah, I've flown out of Syracuse. I just don't think I've flown south out of Syracuse. From the air, you're supposed to be able to see them pretty well. They call them drumlins because they're kind of shaped like drumsticks. They're chicken-like things. And all that is true. All that is true. You might have even grown up watching the Ice Age movies. I like that silly little squirrel thing in the beginning. That's about it for me. I'm not a fan of Ray Romano's voice, but good movies-ish. And you know that takes place, on and around a glacier. And you've probably heard me talk about these mile-high walls of ice. I like to emphasize that a lot. How much its effect on sea level, and all that is true. But what you've been staring at for the last, 5 minutes while I babble about all the things you might know about glaciers, is a glacier. See those white river-looking things? There's 2 of them in here, and a couple off to the side to feed them. That's a glacier. These are alpine glaciers. They're up in the mountains. This is what everybody's fussing about that are melting back. In Asia, in many parts of Asia, these are like the sole source of water for a lot of communities that live at the bottom of them when they melt in the spring. Climate can vary significantly from the top of a mountain to the bottom of a mountain. So it's kind of a big deal for them. Bigger deal for us maybe that we're losing a little beachfront property or something as sea level goes up. Some people will, some people will die if this keeps up. But let's go back to these happy little rivers of ice. That's really what they are, is a river of ice. And the scale here is really hard to tell. Don't get me wrong, these are huge. Okay? But this is not the same thing as those mile-high wall of ice that we talk about and you saw in the Ice Age movies and so on and so forth. Presumptively, these grew into that over thousands and thousands of years, and we had an ice sheet reaching from, let's say the North Pole all the way down into, Massachusetts, New York, Pennsylvania, Ohio, all the way across to right around the middle of the Midwest, really, in the last ice age. 10 to 15,000 years ago, depends where you were. New York, it was about 12,000, I'm sorry, Ohio, where I first learned this stuff, it was about 12,000 years ago. Ohio's a bit southern, so it melted back, earlier. New York State, you're looking 10 to 12, and just, goes back from there. You ever been out Cape Codway? That is all glacier out there. So a lot of stuff you've seen and poked around in is all glaciated, which means that any of the stuff you see around here, streams, features, whatnot, again, as long as you don't go too much further south, maybe an hour or so, the extent of the glaciers, is all about 10,000 years old. Geologically speaking, you should have known by now that's not real old. So this is all young, fresh stuff. Here is sort of a zoom in. Probably not the same glacier at all, but a much closer view. And you see this sort of trough here off to the side, and it winds through the back. Again, scale is way off, I'm sure, because that's a really high peak, I'm guessing, right here in the foreground. And not just something you might scamper up along the side of the road or something like that. So how do we get these rivers' ice, probably is the better question. Where do they come from? How do they form? It's going downhill, right? You gathered that, presumably. They only move uphill when they melt. They're not really moving uphill, they're just melting back. But as they're growing, they're snaking downhill. You saw one in the previous slide here. It's kind of implied. I wouldn't exactly call it a cliff, but they're going over a ledge. So in order to get these, we have to have a buildup of snow. Here in New York State, you have no problem believing that we could build up snow long term. I do think all of the parking lot piles are gone at this point. I think. I haven't been over in Best Buy's parking lot for a while. Might still be some of the back of Walmart's parking lot. You never know. So we understand that snow builds up. But, as this shows you, you could go a whole lot souther, and as long as you go up in elevation, you're still going to get snow. You could find a high enough mountain. All right. And as you see, this says permanent snow. This isn't even just in the winter. So at the equator, if you could go high enough up, the Andes, very, very, I don't think they're exactly equatorial. They're dang close, though. Okay, come to mind. But even let's just pick some tropical, let's just say Hawaii. Let's say there was a mountain high enough on Hawaii. There would be permanent snow there. Something that you think of as very, very warm. So as you see, that works from the north to the south, from the equator. The higher your latitude, the lower you're going to come across this permanent snow at a lower elevation to the point of its sea level, which we do, of course, associate with the north and south poles. So we've got to build up that snow year round. This we also sort of have a crash course in here. A handful of you in the dorms maybe haven't experienced this, especially if you're not from around here. But I like to call them roof glaciers, and we also get into the driveway glaciers. That stuff that forms at the end of the driveway from all of your shoveling. By the end of the season, that's some pretty solid stuff. right? It's not just that snow, that slush that the plows throw in. It hardens, it freezes, and then more stuff comes on, and that hardens and freezes. And the same thing is true with our roofs. I learned that very early on here. The size of those things, I had no clue. First time I'd owned a house, we've been, up this far north as well. And there's, a bunch of snow and crap up on my roof. I'm like, I got to get that down. That's probably not good for my roof. So I'm poking at it with a broom handle and a rake and so on and so forth. And I heard a really, really sickening kind of noise. I'm like, I better move. And 20 years ago, I had moderately cat-like reflexes, believe it or not. I jumped back just out of the way, kind of landed more or less at my toes. I never weighed it, but it was a little more than waist high on me, wider than me, thicker than me, and solid ice. Would have brained me for sure. And that's the heat escaping our houses, melting those little bits of snow that pile up there over and over and over again, compacting it into, again, glacial ice. And it doesn't take 130,000 years, like this diagram shows. So, you're going to see the word fern. Actually, that says firm snow. You're going to see the word fern in a couple times in here. These little snowy ice pellets. All right. And I half wonder if that wasn't some sort of typo that they meant to put in there to say it was supposed to say fern. But so you have your nice, pretty snowflakes. All right. And then this granular snow, which is slightly melted, or in this case, they're implying compaction, down to these snow pellets, and then those snow pellets slowly but surely turn into ice pellets. And again, you know this, we've all had that hunk of snow on our hand that we've compacted a little too far and then thrown it at our brother or sister or friend, and it hurt like heck because you started to turn it into ice. Or you've been hit by one. So we know the process here. And this is just Mother Nature doing that on a very large scale, on a very long time period. And that snow that builds up turns into ice. Just another view of it. And you see that word fern I was talking about. I think what's important about fern is that it's where the snow officially stops being snow and turns into ice. So where can we make this? Well, it looks like half this diagram's cut off, but it's not. It's just way down at the bottom of the slide here. I mean, there's a little bit cut off. It's weird. It's not cut off on my computer. Did it fix itself for you guys? Yeah, it's just missing a little bit of trim. So, permafrost. You may have heard of permafrost. Permafrost is more or less what it means, but it is referring to the soil. All right? Not just frost on your car or your windows or the grass or anything like that. What it's talking about is frozen soil. That's what permafrost is. And permanent as in all year round. So we have the very northern, of course, you can expect that, where the whole dang area is just frozen. Discontinuous means it's spotty. The get some for a while, then it'll disappear, you get some for a while. More than likely that's elevation based. Then we come down, we've got the Rockies running along the west over there. So again, we're going to see alpine. Anytime you see the word alpine, I use the word alpine already. It's just referring to mountains. Anywho, we're going to, and this is current, right? Or at least 20 years ago when the slide was made. I don't know if it's worth updating yet, but probably has changed. Anyhow, what we want to look at for the moment is the dotted line that goes along the bottom there. Now, I told you where the glaciers came through. That is a little different than the permafrost. It's going to be cold in front of the glaciers. So that does not necessarily mark a glacial line. You will see that line a little later, I think, though. So again, things shifted significantly. So they make a huge stink about how glaciers flow. And admittedly, this again is one of those topics that you could take 14 weeks on. I did not take a semester in glaciers. As much as I think they're cool, I don't know that I would have been able to deal with that. So they talk an awful lot, and it is kind of cool, I guess, the way they move. You could picture these sort of flowing much in the way your generation, you guys grew up with making slime and all that. You might be a little old, I'm not entirely sure, but I have a feeling you guys made some slime in your time. And imagine that kind of sliding down an incline, okay? That's sort of the way this moves. Not exactly tumbling, okay, but there's sliding happening, and then there's also a little bit of flow forward and then overturning because of that. All right, imagine the front of your slime sort of pulling up under as this thing slides down, you know, say a folded up Monopoly board or something like that, piece of cardboard. So they're going to talk about that a lot when you read this chapter. They're also going to talk about the fact, and that's one of the things this is trying to show you here, that it doesn't flow, all parts don't flow equally. Parts that's in touch with the Earth is going to be a lot warmer than, say, the part that's way up at the top exposed to the elements. And in fact, the part that's up top is even going to have a much different consistency. It's going to be, going back to your slime. It's going to be maybe old and dried out and kind of, got a skin starting to form on it, getting kind of crunchy. All right. Again, it's up top. It's exposed to the elements. It's much cooler up there, and we start to get these cracks. And these cracks, we're going to give you a vocabulary word for them eventually that form, and they're a function of the flow. Also, talking about the bottom again for a second, because it's warmer down there, all right, there's actually liquid water, and that helps lubricate the glacier. It helps it slide down the mountain. So this is a cross-section view, and again, there's some arrows about flow. We're going to ignore those, because right now I want you to be more concerned with the anatomy of a glacier parts. And we are still over-zoomed. I think that's mainly been the problem, is we're over-zoomed. We're going to use this nice fancy diagram. And then afterwards, I'm going to show you what you'll see on the test. It's a little more basic. So we're going to start up at the top, because that's where glaciers start. With the zone of accumulation. What do you think happens in the zone of accumulation, you guys? That's right. The snow accumulates there. That's where it builds up. This is the feeding zone. Okay? Again, you're uphill. Remember we taught you about uphill. You're going to have different weather, different climate. Again, scale. This could be, a mile or two. Okay? Significantly different weather. And so zone of accumulation is the starting pot. This is where that glacier started, however many thousands of years ago. Sometimes millions. Then I want to skip that word that says snow line for a minute, and I want to go down to zone of ablation. Now, some books use ablation, some books use wastage. This was a really good diagram, so I used it even though I don't use the word ablation. We're going to call this something simpler and implicative of what happens there. Zone of wastage. Okay? This is where the glacier is melting away, flowing away, breaking away, all those things. It's also where it's growing out, the very bottom. You can imagine your slime spreading out as it goes down that slope. But the weather's warmer. Heck, it might even be raining down here instead of snowing like it was up top. And all that leads to the breakdown and the wasting of that glacier. So we have the zone of accumulation and the zone of wastage. In between that is what they call the snow line or the fern line. There's that word fern again. And much like you have the tree line when you're going up a mountain, the last places you're going to see vegetation and all, at least large vegetation. All right? The snow line's kind of like that. The snow line marks the end of the zone of accumulation. In other words, it marks the area where we have the last permanent buildup of snow. We don't see seasonal melt really above that. So the snow line or the fern line is in between the zone of accumulation and the zone of wastage. Arguably, that's not a static spot. It moves. This semester, at least, we haven't talked about groundwater yet, but you may be familiar with something called the water table. All right? The water table is basically the level of the water underground, and again, that is something that can move, depending on whether or not you've had a lot of snow melt or a rainy season, or it's the middle of July and it hasn't rained in a month. That might be higher or lower, right? So this snow line could move a little bit as well. All right, so anyhow, zone of accumulation, zone of wastage, snow line or fern line. What else is going on here? Well, we want to learn another word. We want to learn terminus. Terminus is the front bottom of the glacier. And this is where stuff is really breaking down. This is way down the slope. Meltwater's coming out. All those rocks we were grumbling about finding in our fields are tumbling out here. And should it be near a body of water, which if one wasn't there before, it often tends to form because of all the meltwater, we talk about icebergs breaking off. The process is called calving. You see that word on here. So calving is basically the bits of the terminus breaking off and falling down, splashing into body of water. There's lots of great video of this happening. People go on those, Norwegian cruise lines or some such thing, the Alaska cruises, and they love to take you by the glaciers. And every so often, somebody's lucky enough to get have the video on when one of those breaks off, and you just hear this horrible noise and the big splash. So we don't need to worry about flow trajectory. We don't really need to worry about meltwater pool on glacier or meltwater tunnel or meltwater stream, at least for right now. Again, I want you guys to think more about the anatomy of a glacier, the parts of a glacier, and then we did include iceberg formation as well down at the bottom there, calving. We got one last word on here, sublimation. Who could remind us what sublimation means? I believe that will be on this test, because we haven't tested water cycle yet, I don't think. Sublimation is phase change from solid to gas. All right, so what they're saying is not only do we have a phase change from solid to liquid here, melting, but we've got the surface of these glaciers can go straight from ice too. So we're still in the background, have that water cycle hovering over us. We left it a little while, talked about some other things, now we're back. There's a much cleaner view. Still talking about the flow. We don't care about the flow. Zone of accumulation, fern line, zone of wastage, terminus, some meltwater. Here's what you're going to see on the test. So you want to pay careful attention. I know you guys aren't feeling really chatty this morning, but what do we think D is pointing to? Yeah, exactly. And so that must make C the fern line or the snow line. So what would B mean? Yep, but I call it wastage. If I think about it, I will put ablation on there as well. But yep, zone of ablation or zone of wastage. And then we got A as the terminus. Good job. $19.99. This is probably made in Windows 95 in Paint. I like Paint. Paint went away eventually, though. I think Paint's not still around, is it? Simple MS Paint. Yeah. Is it really? That's awesome. I haven't been on a Windows computer in a very long time. I remember it getting complicated, but that's probably for my simple mind. All right. So again, Lord only knows the scale here. I'm guessing that a hiker or 3 would be not exactly dots, but probably ant-sized on this. This slide is about crevasses. And yeah, I know it sounds and looks a lot like crevices. They kind of are. But crevasses are not good for hikers at all. And yet people do hike on these things, believe it or not. Nobody's there, they're not a problem to anybody. So that's why I'm putting them in the context of hikers. Remember we told you the top of the glacier acts differently than the bottom of the glacier? And I don't mean bottom down hill, but like picture a brownie, the top of the brownie versus the bottom of the brownie. All right. So the top of the glacier is really rigid, frozen solid. The bottom's a little more malleable and melty. So we're up top here. So when that bottom bends to go down a curve, go down a hill, go around a curve, whatever, well, the top can't react the same way. It cracks to accommodate for it. So if you're flying overhead, you can kind of tell, the direction of flow on these things, which is kind of neat. But the problem is, as I said, that a lot of people do go and hike in these areas, whether they're studying them there or they're just paid good money to go wander around in the frigid cold. So let's say you set up your camp and you get that obligatory snowstorm overnight, and your tents are all covered in, and you dig out, and then, all right, time to set off for the day. Well, again, scale is really misleading here. These are giant, giant cracks oftentimes. And you can be walking along under fresh snow, and if you get too close to the edge of the field, you go right through, collapse through the snow, fall into one of these things. Short of setting a movie in that way, I'm really surprised Hollywood hasn't made more scenes like this. But it is kind of hard to put people on a glacier plot-wise. I mean, so but yeah, that would definitely be a drama point if we had some hiking out in the frigid weather kind of movie. So much bigger, you see. But again, for studying purposes, they're very indicative. They're very helpful. They're flow lines, essentially. Really bad for hikers. This slide is here really just to remind you guys that, remember wind, water, ice, and gravity, right? Wind, water, ice, and gravity are agents of weathering and erosion. This is ice. We're there. At the time with ice, we talked about frost wedging, the fact that water expands when it freezes, right? And that it could wedge loose some chunks. We talked about potholes. And I joked about glaciers being, nature's snow plows. These things are huge. They carve out valleys out of rock, okay? Well, more than likely there was some sort of valley already there or wouldn't be traveling down it, but they make them way bigger. So that sort of goes without saying about that aspect of it. But however, right, they're also pulling up a lot of material from the bottom where the glacier's chugging along and grinding up sediment. There's a lot of stuff going on here. So that's the weathering aspect of it. Remember, erosion is transportation. And we actually started our lecture by all these people complaining about how many rocks and whatnot are in their fields, and they're trying to pick them out to farm or to garden or whatever you may be doing. There's two ways to get a whole bunch of rocks. One is to be really close to a stream, and then the other is just a sheeting of this from the glaciers. Around here, we got both. We lived near Sequoia Creek, and when we first moved in years ago, wanted to put up a fence. Because South Utica has really tiny yards, and there's like zero privacy. So I dug probably 2 holes for fence posts and had like 3, the 5-gallon plastic buckety things. Had damn near 3 bucketfuls of rocks in just digging 2 holes. And I said, okay, this is officially the first thing I'm hiring somebody to do for me. Because I didn't have the right tools. I was doing it with a shovel, post hole digger, but, still a hand shovel, or a hand digger, whatever it is. But, yeah, it's crazy with the stones. You drive up north, go up towards Barneveld, Remsen, up that a ways, Old Forge, and you see these farmers' fields, and you see these walls of rock. They didn't have that stuff imported, okay? They got hit with the plows over the years. They throw it off to the side. What else are you going to do with all those rocks except, build a wall? Cobblestone street, maybe, if you wanted one, but we prefer highways nowadays, So, paved roads, whatnot. But, so they dump an immeasurable amount of material. Similarly, you might have driven past some business that has this giant, like Volkswagen bug size rock sitting in their front yard. Or you might go to a college campus and there's always the rock that everybody paints on and so forth. There's a vocabulary word. You'll see it again a little later. I'll use the word now. It's called an erratic. All right? And it's for these giant boulders that the glaciers just drop out as they're melting away. They picked it up, around here. They picked it up in Canada. Any granite you find around here,
came down from Canada. We don't have granite here. But yet there's granite boulders and pebbles and whatnot all over the place. So all that stuff. So glaciers, weathering, and erosion, yeah, totally. We also started by talking about the Finger Lakes. The Finger Lakes used to be streams coming out of, we didn't call it Lake Ontario at the time. Well, there were the locals there, but we don't know what they called it. But geologists have a name for a slightly different version of Lake Ontario there. And these were rivers, okay, attached to that. But when the glaciers came through, they gouged them out. If you don't know anything about the Finger Lakes, they're super narrow, hence the stream part, but they're super deep, which is not typical for a stream. But that's what the glaciers gouged out. So, again, just example after example after example. And you'll see an aerial of those a little bit later. Okay. A lot of vocabulary words. All right, coming up. This chapter is full of vocabulary. Seeing as we, at this point, this semester, we only have 3 lectures left before test 4. All right, that's a good thing because you're getting a lot of vocabulary in this lesson. So in a minute, I'm going to hit a slide, and we're going to go to a slide that shows all of this, but with the snow gone. And I might bounce back and forth a couple times. So this is where the glaciers are here, present, obviously. And that, this is where they've melted back. It's the exact same scene, just missing said glaciers. So these are the glacial valleys. All right, you got one here, you got a nice long one here. You got them all over the place. This mountain has been seriously carved up by glaciers. One of the things that you'll see over and over again, they're very, I don't know what, fond of particular, but there's no word that I could come up with here. They just really like to make a point that glaciers leave a U-shaped valley. And again, these are big, wide, deep, thick things. It sort of makes sense, I guess. Why do they bother telling you that? Well, streams, they say, make V-shaped valleys. So, arguably, you're supposed to be able to look at a valley and say, oh, that is a glacial valley, or oh, that is a stream valley. Problem is that 99% of the time, the glacial valleys end up with a stream in them. And 99% of the time, the stream valleys end up with floodplains on either side, which don't make it look like a V anymore. Anyhow, you can't really, but there's no arguing with them. And understandably, on day 1, sure, it was shaped like a V. Sure, it was shaped like a U. At any rate. So that's what the whole U-shaped valley. And like I said, when you read through the chapter, you'll see that mentioned a handful of times. So we've got all these U-shaped valleys coming out of the top of this mountain. And the features that are left behind after this mountain is carved up is what we are naming. So we're going to start by talking about something that forms at the very back of these valleys, the very beginning of the valleys. Remember, starts uphill and moves downhill. And that is something called a cirque. The word is right over here. All right, I think that was a much better example over there, which is why I was pointing there. Okay, cirque with a Q. And a cirque, which is right here, is a lot of hyphens in here. A steep-backed, bowl-shaped depression. Steep-backed, bowl-shaped depression. So here is your very steep walls in the back. And this is where the glacier is sort of digging its heels in. This is where it's all started. This is where it's pushing off from. And it just tends to carve out a valley that's very, very unique. Cirques are, as I said, at the very top of all of these things. Well, obviously you can't see the top here. But in any of these here where you have you're going to have that steep back bowl shape. This one's just slightly rounder. They took the opportunity to make it really bowl shaped, I guess. So at any rate, so that's what a cirque is. And a cirque starts all of this. Next, we're going to jump to arête. All right, I think that's how you pronounce it. I never took French. But arête, sometimes I say arête. I think it's arête. Arête is this ridge. You've got one here. You've got one here. You can see it maybe a little better when the snow's in the way. The implication also, by the way, is that the snow used to be a lot higher in these things. I think we're at some melt stage right now because, of course, it did start up here to gouge all of that down. At any rate, so this narrow ridge in between these glacial valleys, oftentimes, you know, set up by these cirques in the back, that's called an arête. There's one with an intrepid hiker on it. But right here, we're following this ridge line. All right, so you got one glacial valley off to this side, one glacial valley off to this side. All right, next. Next, we've got Horn. Horn is the top of said mountain that is carved out by cirques, that is full of glacial valleys. Okay, it's kind of hard to see. In this one, it's pointing right here. Some folks might say Horn of Plenty or think of something like that. However, there's one there. One of the most famous horns, anybody knows, everybody knows, I mean. It won't probably come to mind. Somebody tell me, what's the most famous horn? You actually know it. It's a ride at the fair. The Matterhorn. It's that silly roller coaster that goes around in circles really, really, really quickly, kind of small, goes up and down. They have some Arctic background on it. At any rate, it's at all the fairs and festivals. Well, not festivals, but at the bigger fairs. Matterhorn is mother's horn. They were thinking about boobies when they named this. Okay? Those shepherds lost out there with their sheep, watching them. That's what a horn is. So, smile and nod when someone says, oh yes, Horn of Plenty. No, that's not what they were going for. Unfortunately, they were quite crude and rude. But that's Horn. What do we got left? We got truncated spurs or hanging valleys. So, hanging valleys are much cooler. Truncated spur is the same thing, but like next to it. Here's a great example, even though it's labeled over here. You've got all these glacial valleys coming down here. We talked about the cirques. We've got the arêtes dividing them, so on and so forth. And then, boom, this guy comes along and cuts right through everything, which leaves these that used to follow all the way down, one could imagine, right? He just plowed and cut them all off, leaving very steep cliffs or ledges here. Well, again, these are areas that tend to get a lot of water, or you wouldn't have had snow in the first place. You get really cool waterfalls from these hanging valleys. The truncated spur, as I said, is just the arête that's been sliced off. So again, imagine at some point we had a glacier coming through here. But then after that, boom, a guy came through this way, sliced it right off, and now you've got a nice pretty little waterfall. So that is a set of weathering features. We had that weathering and erosion slide there for an introduction. So these are all ways that glaciers can weather a mountain. We're switching gears now to erosion, or more so the end of erosion, deposition. And this next set of features are depositional. All right? In your minds when you go to study, hopefully they won't blur together. I don't really nitpick it apart too much, which of these, at least traditionally I don't, which of these are weathering, which of these are depositional, but these are definitely deposits. So the key word here is moraines, all right? These moraines are ridges of sediment that melt out of the glaciers. You find them along the sides of glaciers, you find them in the front of glaciers. And it's the ones in the front that turn into real buggers, okay? You're going to be cursing them in a couple minutes, at least probably quietly to yourself, and on the test as well. So let's start with the easy ones, all right? The ones along the side are called lateral moraines. So we've got them here, and in between each of these little glaciers, we've got a lateral moraine as well. However, first caveat, let's jump over to here, it's a little simpler. All right. When it's in between two glaciers, they call it a medial moraine, as in a median on the road. So even though this one is alongside a glacier, there's another glacier right next to it. It's in the middle. Medial moraine. Now, these would all be medial moraines. Any one of these three. You'll see my diagram doesn't make this quite so complicated. You're welcome. So lateral moraines are along the side. A medial moraine is a special kind of lateral moraine that is betwixt two glaciers. And you see here how a lateral moraine can all of a sudden become a medial moraine. This lateral moraine merge, lo and behold, glacier, hey, it's now a medial moraine. A lot of this stuff is relatively speaking kind of terminology, which again makes it annoying for you guys trying to memorize it in a short period of time. All right, and as I said, those are the easy ones. Next, we've got something called an end moraine. An end moraine also seems quite simple. An end moraine is at the end of the glacier. Makes sense, right? Lateral along the sides, end at the end. Good. However, it's when you get multiple end moraines that things get confusing for you guys. Why do you get multiple end moraines? Because as the glaciers keep melting back, they're going to leave new piles of sediment. What happens is these ridges build up when the glacier, again, is melting out. The water flows away, but the sediment piles up. Okay? So every time it has a big moving event, a big melting event, it's going to leave the old ridge behind and start forming a new one. If it stays there long enough, it'll build up a nice sized pile before it moves back again. So you end up with multiple end moraines, and when they have those, they jump to this word, recessional moraine. All right, a recessional moraine is any moraine. I probably should have went to terminal moraine first. Let's go to terminal moraine first. Sorry. So when you get multiple end moraines, they call the last end moraine a terminal moraine. Okay? It's at the terminus. Remember, terminus was the end of the glacier? That's why we use the word terminal here. So this marks the farthest extent that the glacier had moved up to this point. It is the last end moraine, or first, depending on your perspective, right? But All right. Then any moraine behind the terminal moraine becomes a recessional moraine. So, end moraine is a moraine at the end. We have special kinds of end moraines. When we have multiple end moraines, we're going to call the last end moraine a terminal moraine. And then all the moraines behind it become recessional moraines. You could always just sort of picture the word end in parentheses. It's a recessional end moraine. Got one more word here, ground moraine. Ground moraine is when there's just a steady melt back, and it doesn't stay long enough to build up a ridge or a hill. It's more like a sheet-like covering. Picture a steady melting back over days and days and days, and it just leaves this mess in front of it. But again, it's not in one place long enough to pile up and make a hill. So ground moraine is also a type of end moraine. But I argue I like to overthink things. Some of you do when you're taking the tests, I know. If a moraine is a ridge of debris, ridge of sediment, and we just told you that a ground moraine is not a ridge but a sheet-like deposit, why do we still call it a moraine? I don't know. I gave up worrying about that a long time ago, but I know some of you will think that you're confused, so I just want to let you know you're not. Ground moraine is a sheet-like covering, and a moraine is a ridge of sediment. Lastly, we have outwash. Outwash is exactly kind of what it sounds like, okay? That's just the debris that washes out of the front of the glacier. Again, we've got lots of different vocabulary words. Some of them we're going to talk about, some of them we aren't, for the terrain that's left in front of a glacier. But we wanted to get these deposits and the weathering events down first. Now, you last saw one of my amazing diagrams with the glacial anatomy. We've got one more here, again, in an attempt to clean up some of those diagrams, make it a little easier for you guys. But you got low tech. Again, it was 1999. So we got Glacier A and Glacier B. And we're looking at moraines. So let's look at hopefully an easy one here. What do we call Z? We got a Z here. We got a Z here. What was the one for the word? The word for the one that's on the side. Anyone remember that? That was lateral. Lateral moraine. And when a lateral moraine gets wedged in between another glacier, what would W be in this case? Medial moraine. So we got a lateral moraines, we got medial moraines. All right, what did we say the moraine at the end of a glacier is called? There's only one of them here. There's only one. So it's just a plain old end moraine. Over here, we've got multiple moraines, so S does become a terminal moraine in this case over here, because you got moraines behind it. You only use the word terminal if there's more than one end moraine. Otherwise, it's just an end moraine. You'll see in a moment kind of how this actually plays out. So that leaves, well, let's throw an easy one in here, this little smattering of stuff here. We'll call that the ground moraine, right, the sheet moraine. So that makes this here guy, X, is a recessional moraine. So even though it's at the end, we have to use a special word for it because there's stuff in front of it. All right. So this is recessional moraine. This is a terminal moraine. But over here where there's only one to worry about, we still call it an end moraine. Now, to my point. From above, okay, they call this alpine geology. This is a good way to do geology. You find the highest peak and you sit there and you look around. All right? It's a good way to get an overview, literally and figuratively. So this glacier is doing what? Is it growing? Is it receding? What do you guys think that Glacier A is doing? I'm not going to answer for you this time. Got two choices. Because why? Because you see all this recessional moraine stuff? It's receding. It's shrinking. Okay? So because you see all this stuff here, it's only going to drop this guy, all right, and this stuff if it's shrunk back from here. Remember, it was here. So now it's gone back to here really quickly. It stopped here for a while. How do we know? Because it's built up a hill. All right, so at the moment, as this snapshot was taken, you're sitting on a hill looking out over this whatever. You could assume that this guy is in recession right now. He's melting back because of all this riffraff in front. But over here, well, we don't know. Arguably, you could assume, okay, if this one over here is melting back, this one would be melting back. I get it. But, you know, just argumentatively here, we can't tell because we only have one moraine. Okay? And at the moment, that one moraine is an end moraine. For all you know, tomorrow it could plow through there and it starts growing. Or if it moves back, well, then it might start growing another moraine. Right now, in this snapshot, you cannot tell what B is doing. But we got a pretty good idea that A is going backwards. A is receding because of all this stuff here. So there is some logic to having all these extra vocabulary words in here. All right. This slide and the other drawing are both on the test. And like I said, this is a lot of points. 1, 2, 3, 4, 5, 6. And then I think there is a question or two about the glaciers. So right here is like a letter grade. Okay, if we have a 50-point test. Look at this thing. Not the best picture. I don't know why I don't have a better picture of moraines. But I did include this because it's usually a mess in front of glaciers. Okay, and this is a great picture of a mess. Every semester I struggle to figure out why I included this here. Maybe it's a perspective. Maybe from out there where you guys sit, you could actually see some delineation, some detail. All I see are different colors. There doesn't really seem to be much elevation difference. It's just a mess. Unless, of course, this white thing here is actually glacier. Then the rubble along the side, I could argue, is lateral moraine, but it's a horrible angle. Horrible angle. This one, however, you can actually see something. You can see a couple things. So right here, you've got lateral moraine. Okay? It's off to the side of the glacier. It's also, this picture is, and they never told us how much time has gone by here. But this is a glacier receding. Same spot, guy took a picture, 10, 20, 30 years in between. They're both black and white, so, you know, I suppose it could be seasonal. Anywho, so what we see here then is the glacier receding back. We see a water hole on top here forming. It's vaguely maybe sort of starting right there. All right, but we see a huge amount of melt back, and then the exposure of that moraine is even more so. The side snow's gone away in a good bit. And it's also easier to tell how that sucker was snaking around. And again, scale on here, this is a lot bigger than, this is not you standing here with a camera watching the tide come in kind of. This is big. This is big. This is a pretty decent view. Glacial Valley, and see what I mean? How up here, sure, it was U-shaped, but down here it's filled in with so much sediment, and there's streams there now, it no longer looks U-shaped. The moraines have vegetated themselves. So again, if you're walking through this, you're just going to notice a very steep-sided valley, perhaps. But from a plane, this is a wing support, I think, on a plane. You could make it out much, much better. Glacial geology was originated by the shepherds, okay? I wasn't really joking when I was talking about the Matterhorn there and these lonely shepherds out for months at a time, with the flocks, staring at the mountains and eating their goat cheese and drinking their goat wine. Those early observationalists we talked about in the very beginning of the semester who gave us a lot of science. Glacial science, definitely, at least the features, recognition of features came from them. So, at any rate, so some moraines and a good example of what they did mean for a U-shaped valley. All right, so we've been talking about this debris left behind by glaciers. I've called it sediment, I've called it debris, I've called it rocks, boulders, gravel. So we've got one word that sort of loosely covers all of that. And instead of just calling it sediment, they want to specify, they want whomever they're talking to know that it is sediment left behind from glaciers. They would use the word till. Okay? So till is glacial sediment. And because it's usually just dumped out, we only talked about sorting a little bit in here, how the agents of weathering and erosion can sort. Okay, till is generally a jumbled mess because it sort of just falls out of the melting glacier. Yes, there are streams that form in front of glaciers, and yes, they will sort things, but not a whole lot. Not a whole lot. So generally speaking, till is unsorted debris and left behind from a glacier. We already had the term glacial erratic. That's those large boulders that would be dropped out. They would be mixed in with the till, arguably. The till is much easier removed. And this is another view of what goes on in front of a glacier. Got a lot of vocabulary words on here. Some of these we're going to talk about in greater detail, some of them not. You heard me mention drumlins before. I did not talk about eskers. You got these sort of eskers. I don't think it means snake, but they're these snake-like deposits that form underneath of a glacier. And we have some moraines that were cut through by meltwater. And then you're going to hear about kettles, kettle lakes. These happen from calving. When giant hunks of ice fall off, they actually leave these giant dents, and then they melt. Again, if you've been lucky enough to get over to Cape Cod area, those inland ponds that they're so fond of over there, and if you've not been to the Cape Cod area, when I go, and we don't go a lot, it's too cold, the water's too cold. I'm all about waves in the coast. I like to sit there. But the folks, the natives that live there, they're all about their inland ponds. okay, these little lakes. They're all over the place. Those are supposedly all these kettle holes, kettle lakes, they call them. So we told you that Cape Cod was heavily glaciated, and it is definitely pockmarked. So at some point the glaciers were dropping these giant hunks of ice, calving, so you were at the end of the glacier, and it's still there to this day. Probably the high water table to thank for that, since they're more or less at sea level. But they are freshwater ponds. So. All right, we're going to call it here because there's just a whole other slew of vocabulary words coming about some topographical features that are left behind. I don't want those to mix in your brain with all these other features we've been talking about. And I've actually been talking for a little over an hour anyhow, despite what this timer up here says. Looking at the recorder, we're at over an hour, so we'll pick up next time.